Hello everyone, welcome to this video on the permutations and combinations series. This video we're going to talk about the permutations too. We're going to focus on the digits and the arrangement of numbers and digits to get a better understanding of permutations. So this is the fourth part of the series. We have already done videos on basics like counting principle, permutations and combinations. Make sure you watch them so that you understand this better. This video is brought to you by Learning Made Easy team, a team of IIM grads in association with our e-learning partner GTCUBE Get to the Top. If you are watching this video in the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these videos as part of a course and also get to practice a lot of questions. So let's get started. So as we have already said in the earlier video of permutations 1, arrangement of people, arrangement of letters, arrangement of digits, it's all the same. Right? Generally, the digits arrangement, you don't get a clue like which digits should be arranged. Sometimes they would give it as an extra condition. Normally, what are the digits we see in numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the 10 digits that we can put in numbers. So let's say I'm trying to understand how many 3-digit numbers exist in the number system. So that means a 3-digit number will have 3 blanks, right? They should have 3 digits. So as I always said, let's look at the number of options available for each blank to find the total number of possibilities. So for the first blank, what are the number of possibilities available? Like these digits, right? I can put any one of these except 0. Why? I cannot start with 0. Whatever I put here, right? 099 is a 2-digit number, 99. That's not a 3-digit number. So a 3-digit number should not start with 0. It can start other than that with any other number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Anything is fine. So I have 9 options for this, right? Because I cannot put 0 as my starting digit, I cannot consider that to be an option. So leaving that, there are 9 options. Coming to this part, I can use any of these 10 digits, right? I can even have 0. Like I can have a number like starting with 2. Then I can have 0 and 0. 200 is a 3-digit number. 207 is a 3-digit number, so 307 is a 3-digit number. So yes, I can have any one of those 10 digits. So I can put any one from those 10. Again, for the last digit also I can put any one from the 10. So the number of 3-digit numbers is 900, which is true, right? The smallest 3-digit number is 100, the largest is 999, and these are basically 900 such numbers. So let's assume if the repetition is not allowed. Like here I've counted that I can have 200, right? I can have 355. These are all counted. Let's assume if the question asks how many 3-digit number exists in the number system where all the 3 digits are different in the number. So again, I start off with 3 blanks. In the first blank, I cannot put 0. Leaving that, I can put any one from the 9. When I come to a second blank, how many options would I be left with? 9. Why? Whatever I select here, I cannot repeat it here because the 3 digits are supposed to be different. But it's not 8 because 0 was not counted here, but 0 should be counted here, right? That's the point. Understand this again? So my first digit, if let's say it's 1 in my hundreds place, I cannot put 1 here. I cannot have 0 here because 0 is not a suitable number, a digit for the first blank. So I cannot put this, but 0 is counted here. So because 1 is used in my first blank, I cannot use 1 here. So all other options are accepted. So I have 9 options left. So I still have 9 options here. So 9 and 9. And now I will be left with 8 because I would have used 1 here and 1 here. I cannot repeat these two. So I will be left with 8. So the number of 3-digit numbers that does not have the digits repeated is 9 into 9 into 8. That's 81 into 8. That is 648. Right? So what do I mean by that? The digits does not repeat is like I should not count like numbers like this where all the 3 digits are repeated. I should not count numbers like this where 2 of the 3 digits are repeated, right? If I remove all of this, I'll get 648 numbers where all the 3 digits are different in the number. So the remaining of these cases would be obviously 900 minus 648. So let's look at this question. How many 3-digit numbers are even numbers? So again, I start off with 3 blanks. Even numbers, the only thing I need to worry about is the last digit, right? Last digit should be 0, 2, 4, 6 and 8. So how many options I do have in this last blank? 5. I'm doing it, repetition is allowed, okay? That means the digits, that's why it says 3-digit numbers, right? So a number like 242 is a 3-digit number and it's an even number. So digits are repeated, it's counted. Unless the specifically condition saying if it's just numbers, yes, the repetition is allowed by default. So I have 5 options here. I can put 0 or 2 or 4 or 6 or 8 here. I can put any 9 options out of the 10. I cannot use 0 here. So leaving that, I can use any one of those. And then what is the thing I'm left with? I can put any 10 here. So it's 9 into 10 into 5 is the answer. That is 450 even numbers. Which is easy, right? 900 is the total number of 3-digit numbers. Half of them have to be even. The other half will be odd. That's what it is. So how many different 5-digit numbers can be formed by arranging digits of 1, 1, 2, 1, 1? You see, this is like how the repetition of digits matter. And if I have number like 121, what all can I do? This is 1, 211 is 1, 112 is this. That's it, right? I cannot do anything else. I mean, if I even swap these two, I get 211 only. I swap these two, I get 211. I swap these two, I get again 121, which is what we seen in the earlier alphabet situation also, right? Ape gave me 6 different words. App only gave me 3 because these 2 letters are repeating. That's what we see here also. Same similar thing. I have 5 blanks. So 1, 2, 3, 4, 5. That's 5 factorial ways. By 1 is repeating 4 times, so I just need to divide by 4 factorial. That's why I'll get only 5 different 5-digit numbers. Right? They look like this. 2 1 1 1 1 1 2 1 1 1 1 1 2 1 1 1 1 1 2 1 1 1 1 1 2, right? All of this, the same things. Similarly, this also 1 2 3 4 5 different digits, but in that 1 is repeating twice, 3 is repeating twice, sorry, and 2 is occurring once, so I just need to do this. So 5 factorial by 2 factorial into 2 factorial is 5 into 4 into 3 by 2. So 30 different ways I can arrange this to get different 5-digit numbers. This is exactly same as the alphabets, you know what we did. Like if I have a word like apple, what should I do, etc. Same as just 1 2 3 3 1. Treat them as alphabets and do it. What you've done till now in this is like using the rule or logic of this 9 digits, 10 digits and repeating, non-repeating. This one is as simple as just the alphabets. Now let's look at this. How many different 4-digit numbers can be formed by arranging following digits 0 to 481? Now I am not allowing you to use everything between 0 to 9. I am only restricting you to use these 5 digits. And I need to make a 4-digit number. So how many options I have for the first blank? 2, 4, 8, 1. I cannot use 0 for my first blank, right, for numbers, because if I use 0 for my first blank, whatever I put in my rest of the 3 blanks, it will not be a 4-digit number. It will be a 3-digit number. That's why I have 4 options here. Digits are not allowed to be repeated, right? So I cannot use the digit I use already. So here I would have used one of these 4. So in the next blank, out of 2, 4, 8, 1, 0, I cannot use 0 in my first blank. Out of 2, 4, 8, 1, 0, one of the 4 has been already used here. So I cannot use that. Let's assume if I use 2 here, I cannot use 2 here. So I can use 4, 8, 1, 0. If I used 4 here, I cannot use 4 here, so I can use 2, 8, 1, 0. So I'll be left with 4 options. 3 options, 2 options. So this is 4 into 4 into 3 into 2. That is 96 is the answer. So I can make 96 different 4-digit numbers by using these digits. If digits are allowed to be repeated, right? So if the digits are allowed to be repeated, same thing 2, 4, 8, 1, 0. I cannot use 0 here. So I have 4 options. I have 5 options here, 5 options here and 5 options here. That is 5 into 5 into 5 is 125 into 4 is 500 different 4-digit numbers can be made. Right? That's how we do if we have restriction on the digits that I can use. Not like 0 to 9 but only in this way. How many 4-digit numbers can be formed with the following digits which are divisible by 4? If digits are allowed to be repeated. What is the logic? I'll start off with this. The divisibility rule of 4 is that the last 2 digits should be divisible by 4. So in this pool of digits, what all can I make? I need to check this. I can write 54 here. Is this divisible by 4? No. So nope. 56, yes. 51, no. 50, no. 52, yes. So I have to just check like that. 46, no. 45 no, 41 no, 40 yes, 42 again no, 64 yes, 65 no, 61 no, 60 yes, 62 nope, 16 yes, 14 no, 15 no, 10 no, 12 is again accepted. That's not divisible by 4. 0, 5, 0, 4 is yes, 0, 6 no, 0, 1 nope, 0, 2 no, 2, 5 no, 2, 4, 24 yes, 2, 6 no, 21 no, 20 is yes. Right, so these are all the digits I can put in the last two blanks such that they are divisible by 4, but the digits are allowed to be repeated as well, right? So I can also have numbers like 55 no, 44 yes, it is divisible by 4, 66 no, 11 no, 00 yes, a number ending with 00 is divisible by 4, 2 no. So these two cases are coming up because the digits are allowed to be repeated. So how many I can put in the last two blanks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can put 12 such cases together, right? Two blanks together. What about these two? 1, 2, 3, 4, 5. I cannot put 0 there. So I have options like 5, 4, 6, 1 and 2. Here I can put anything between 5, 6, 1, 2, 0. All 6 letters digits can be put. So the answer is 5 into 6 into 12. Right, so that's basically 30 into 12 is 5, 6 is 30 into 12. So that's basically 360 is the answer for the B bit. Sorry, I did it for the repetition allowed, right? So all the 12 cases is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11, 12 when the digits are allowed to be repeated. And I've also done the same here. So I can actually find 364 digit numbers formed from these digits which are divisible by 4 if the digits are allowed to be repeated. Allowed to be repeated. So I did A only, my bad. If the digits are not allowed to be repeated, I cannot count these two cases. There are only 10 cases in this. Right, like this 56, 52, 40, blah blah blah. So in this case 56, I'm talking about these two blanks. 5, 6 sits in the third and fourth. What are the the options I have for these two? I cannot use 0, right? Leaving 0, I can use everything else. So in this, if it's 5, 6, so what are the options I have for the first blank? I cannot use 5, I cannot use 6, I cannot use 0 because 5 and 6 are already used. The digits are not allowed to be repeated. So I have 4, 1 and 2, 3 options. What about this? I have again 3 options. Why? I would have used one digit here, I have used 5 here, 6 here. Leaving these 3, I can use any remaining 3. So that is 3 into 3 is 9 such cases are possible which will end with 56. Similarly for 52 also I'll get 9 such cases. 64 also I'll get 9 such, 16 also I'll get 9, 9, 9. I'm not looking at 40, 60, 4 and 2, 20. I'll tell you why. When it ends with 0, right, it will give me a different answer. Why? Let's look at this. 40, 0 is used here, 4 is used here. How many options do you have for the first blank? I can use 5, I can use 6, I can use 1, I can use 2. Because 0 is used here, unlike in this case, that's why I cannot count 0 here. That's why I would rather get 4, not 3. In this blank, I've used 1 here, 1 here, 1 here. So I have 3 options. So that is 12. Similarly for 60 also I'll have 12. This also I'll have 12 and this also I will have 12. So 24, 60, 40. There are 4 such with 12 and remaining 6 will have 9. So the answer is 54 plus 48. That's basically 1 or 2. Which is a tedious and a long approach, but this question should be done in this way only. So there is no shorter way for this. So generally you don't get to see questions like this frequently, or maybe very, very rare. The reason why we have selected and we are solving this is to show you and make you understand this, at the fundamental level. So even if it's confusing for you, just try to understand this. If not, that's okay. Don't worry about this, because this type of questions, simple divisible by 4 you might get, but most probably these questions are on different level and they would not be tested in exams. So don't worry about that. So let's solve problems. How many numbers less than 1000 can be formed using the following digits 0, 7, 8, 1, 2 and 4 if the digits are allowed to be repeated and not allowed to be repeated? So let's focus on the digits allowed to be repeated. Understand the numbers less than 1000 are 3-digit numbers and 2-digit numbers and 1 digit. Please keep that in mind. It's not saying 3-digit numbers less than 1000, right? It's saying how many different numbers are less than 1000 can be formed. So I have to look at 3-digit numbers, 2-digit numbers, and 1-digit as well. So how many 1-digit numbers do I have? 1, 2, 3, 4, 5, and 6. So can I count 0 or not is a different question. You have to be maybe specifically write how many different natural numbers or whole numbers depending on which. So let me take it as natural where I don't count 0. So 7, 8, 1, 2, and 4, there are 5 numbers which are single digit that can be formed. 2 digits, I have 1, 2, 3, 4, and 5 options for my first blank and 6 options for my next blank. Because I cannot put 0 here. Here I can put everything 0, 7, 8, 1, 2, and 4. That's 6 options. Repetition is allowed, so that's why it's 30. The third one, again the same thing. In the 6 numbers, I can put everything except 0. The rest of the blanks, I can put everything including 0. So that will be 180. So the answer is 180 plus 30 plus 5. That is 215 is the answer. If the repetition is not allowed, right? 3, 2, 1. 1 will still be 5 because anyway there is no repetition. In this case, I will have 5 options, 0 is not counted. In this case, I will have 5 options because I would have used 1 digit here. I cannot use the same digit again. Leaving that, I can use any one of these 6. So that's 5 into 5 is 25. What about this? Same logic. Everything except 0 can be used here. 5 options are available. Because I would have used 1 digit here. Here, out of all the 6 options, 0, 7, 8, 1, 2, I cannot use 1 which is already used in the first place. So I will have 5. I would have used 2 digits here, 1 and 2. I mean 1 digit here, 1 digit here. I cannot use 2 digits which are already used. Leaving those 2, I can use anything in the 4. So 25 into 4 is 100. So 100 plus 25 plus 5 is 130 different numbers. Right, that's how I should do this. The important point that we wanted to show is this, that less than 1000 is not just 3000. Don't stop it here. Also do 2 digit and single digit numbers as well. How many different numbers can be formed which are in between 500 and 1000 excluding them using the following digits 0, 1, 5, 8, 9, 6. So repetition of digits is allowed. So 500 to 1000 excluding them, I am talking about 501 to 999. There are only 3 digit numbers. I have 0, 1, 5, 8, 9, 6 as options, right? So 1, 2, 3, 4, 5 and 6 digits. I have 5 options here, right? I can use 1, 5, 8, 9, 6. I cannot use 0 here. So I have 5 options. Digits repetition is allowed. So next case I can use all 6, 1 out of all 6, right? And there's nothing that's stopping me from selecting even 0. 6 also here. So 5 into 6 into 6 is 180, right? So I can make 180 different numbers where the repetition of digits is allowed. But there's one complication in this. Oh, sorry, this is wrong. Why? Because I cannot use all 1, 5, 8, 9, 6, 0. It should be between 501 to 999, right? I cannot start with 1. I cannot start with 0. I can start with 5. I can start with 8. I can start with 9. I can start with 6, right? 500 something, 800, 900, 600. All of them are between 500 to. So there are only 4 options, not 5 options. Remaining will be 4 into 6 into 6. This will stay as it is, right? So 6 into 6, 36 into 4 is 144 is the answer, not 180. You should not stop even here. There's one trick in this. Why? This is almost correct. There's one special case that is popping up. I am saying that 5 is accepted in my first digit. So I put 5. Anything is possible here and here. So I'm also counting 500 in this case, right? In these 144 numbers, when I did this 3 blank approach and I did 4 into 6 into 6, I am also counting one number which is 500. 5 is put in the first blank which is counted here in these 4 options. 0 is counted here, 0 is counted here. So 500 is also counted, which is not between 500 to 1000 excluding them. So the answer is 144 minus 1, that's 143. Just be careful on the endpoints. That's the only agenda, the reason why we have said this question intentionally. Just make sure that, are these endpoints causing any problem, and accordingly do it. If the repetition of digits is not allowed, okay, I'm not allowing you to repeat the digits. So 3 blanks. What are the options I have for this? 5, 8, 9 and 6, right? I can use one of these 4. What about here? I can use anything from 0, 1, 5, 8, 9, 6 other than what is already used in the first blank. So there are 6 digits. I've already used 1 here, so I have 5 options. And here I have used 1 here, one letter here, 1 digit here, 1 digit here. So I can use anything other than these 2. 6 minus 4 is, I have 2 is 4 options. So the number of different is 4 into 5 into 4. that is 80. So I can form 80 different numbers which are between 500 to 1000 where the digits are not repeating. Should I do -1 here? No. Why? Because 500 is not counted in this case. Yes, 5 can be put here. If I put 0 here, I cannot repeat 0 here because the digits are not allowed to be repeated, right? So if I have 0 here, I won't have 0 here. So I will never ever count 500 in these 80. So I don't need to do -1. So it's simply 800, right? Just understand this so that you can do this type of tricky problems easier. So that's it. Thank you for watching this video. If you're watching this video in the YouTube channel, make sure you check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these videos as part of courses and also get to practice a lot of questions on these concepts. Practice is the important thing that makes you understand these things better. Also, like our partners Facebook page, facebook.com/gtcube3. We're coming up with a lot of content that would help you in your preparation. So you'll get all the updates and notifications if you follow this page. Thank you for watching this video, and let's meet in the next video.